Yes, friends, I'm Professor Kumar and you are at Galaxy Tutorials. We are picking up from our last lecture, which is on Similarity, chapter number 1, 10th standard, Maharashtra State Board, okay, Maths 2. This is our lecture number 2. Today we are going to see exercise 1.2, but before that we will be doing certain theorems with the help of which we can solve exercise 1.2. These theorems are important. In the exam, we are given to write a theorem, and we also have to fill theorem as an activity, as you know, fill in the blanks. Let us see the first theorem. On page number 7, I have basic proportionality theorem. Which further on we will be referring to as BPT. My friends, do not use short forms in the exams. What does this theorem say? So we start with the theorems. First theorem of the chapter, basic proportionality theorem. The theorem says, if a line is parallel to a side of a triangle. So I have a triangle. We'll do rough work here first. I have a triangle, and my triangle is A, B, C. If I have a line which is parallel, line L, cutting it in P and Q, these are parallel. So I have PQ is line L is parallel to BC base and cuts the triangle at P and Q. So if a line is parallel to a side of a triangle, intersects the remaining sides in two distinct points, our two distinct points are P and Q, then the line divides the sides in the same proportion. That means whatever is the proportion here is the proportion here. So if this is half, this is also half. That is what the theorem means. We will prove the theorem. In the theorem, first we write theorem. If a line parallel to a side of a triangle intersects the remaining sides in two distinct points, then the line divides the sides, those sides, in the same proportion. This is the theorem, my friend. Memorize it so that it comes fluently to you. Now we will prove this theorem. So first, given in triangle ABC, first line L is parallel to line BC, line parallel to line. We have not drawn, but technically it will be also a part of the line, the side of a triangle. Okay, and second, line L intersects AB and AC in points P and Q respectively. Then we have to prove AP upon PB is equal to AQ upon QC. That is what, my friend, it says. We will do construction. Join B to Q and join P to C. Okay, construction. Draw segment PC and segment BQ. And then we will start our proof. First, when two triangles are drawn between parallel lines, their heights are equal. We just saw it in the exercise 1.1. So, I have first triangle APQ and triangle PQB have equal heights. Okay, because both triangles lie, okay, between two parallel lines, for your understanding. And from our 1.1, the 3 points which we have made to exercise 1.1, our first lecture, therefore, area of triangle APQ upon area of triangle PQB is equal to AP upon PB. Okay, that is one reason. Okay, areas are proportional proportionate to bases. Okay, and also area of triangle APQ upon area of triangle PQC is AQ upon QC. This is 2. Reason same. So we take the side triangles or we take the other triangles, we get 2 pairs. Please have a look, my friends. The first one, it is APQ, okay, and PQB. The first we have taken are these triangles. And in the second case, we are taking APQ and PQC. We are taking the other side. We are taking now this triangle. Okay. So, this is how we are having a look. Simple. So, we are having APQ and QPC. So left side, right side, like that is separate. So we get 2 pairs of triangles. We don't have to draw individual figures. Okay, this is for your understanding only. Now, segment PQ is common base of triangle PQB and triangle PQC, because segment PQ is parallel to segment BC given. Therefore, triangle PQB and triangle PQC have equal heights. Okay. So which triangles we are taking? PQB and PQC. Now we are taking these triangles. Okay. We are not looking at the others. We are again between the 2 parallel lines. Okay. So therefore, area of triangle PAPQ, sorry, area of triangle PQB is equal to area of triangle PQC. Third. Base is same, height is same, areas are equal. Third, we have seen in the third case, equal to 1 upon 1 in exercise 1.1. Then we have 1, we have 2, we have 3, sixth. Therefore, area of triangle APQ upon area of triangle PQB is equal to area of triangle APQ upon area of triangle PQC from 1, 2 and 3. Okay, so we will have a look here. 1 APQ upon PQB, 2 APQ upon PQC, and 3, okay, we are having PQB is equal to PQC. So denominators are same, therefore numerators are same, therefore we get ratio equal. Okay, and when we combine, you can see we get this result. Therefore, I get AP upon PB is equal to AQ upon QC. I get the right hand sides down from 1 and 2. Hence proof. This is how to prove the theorem. Okay? Perfect. This is how we prove the theorem. Basic proportionality theorem. So if a line is drawn parallel to a base, okay, in our case or any other side, it will cut the other two sides in equal proportion. 1 upon 2 is equal to 1 upon 2. We will remember like this to solve for the exam. Or x upon y will be equal to x upon y is BPT. Okay. Go through the theorem nicely, learn the theorem, practice the theorem, derive step 1, step 2, step 3, make them equal and write the conclusion. Very important theorem for exam. We'll be using it in the sums also. Please practice. Going to converse. Second theorem. Converse of basic proportionality theorem. In this case, if the ratios of the intersection by a line, okay, cutting the two sides in same proportion, then the line is parallel to the third side. So this is what we are going to prove. So theorem. If a line divides any two sides of a triangle in the same ratio, then the line is parallel, okay, to the third side. That is what the theorem says. Okay, so we'll have to prove this by a indirect method, and it is an activity, okay, which you will be able to fill up by yourself. So I leave it as a homework. Page number 7. Theorem is written for you, theorem is drawn for you, and the fill in the blanks are left for you as activity to fill. Okay, So that is what this says. And in case you have difficulty, please let me know. I will cover the theorem also in details. Okay, because it's extremely simple. Those are reverse steps. So that is how you will be able to do this. And there is an activity which you should check out so that you know that this is correct. Helps in construction chapter. Then third, the angle bisector property. Property of an angle bisector. Of a triangle. Third thing we have to learn. Third theorem. The theorem says the bisector of an angle of a triangle divides the side opposite to the angle in the ratio of the remaining sides. This is what the theorem says, okay, in angle bisector theorem. So, basically, I have a triangle and I have an angle bisector. So, this and this is equal. This is labeled as A, B, C, okay, and a E. Then my theorem says that this angle bisector divides the side opposite side is AB, in the ratio of the remaining sides. Or in simple language, he is saying 1 upon 2 is equal to 3 upon 4. Okay? Or x upon y will also give me x upon y as ratios. So this is a shortcut. Please remember 1 upon 2 is equal to 3 upon 4, and that should help you with the sums, angle bisector theorem. So, given, okay, in triangle ABC, okay, bisector of angle C intersects segment AB, okay, in point E. That is what they have told me. I have a bisector and it cuts AB in E. I have to prove AE upon EB is equal to CA upon CB. This is what I have to prove. To prove, we will first perform construction. Construction. Draw a line parallel to ray CE passing through point B. Okay, so we will be drawing a line parallel to this. So I am going to complete the construction so that it fits on my board, and I will draw a line parallel to this. This is point D. Okay, and that is B. extend AC to intersect it, the BD wala, it at point D. So complete. These are our constructions. This is not present in the diagram. So this is what we have constructed. Okay. Then we will go for the proof. We will prove the following now. First, now you can see clearly in our diagram because of our constructions. Okay, we have got these parallels. Okay. First, ray CE is parallel to ray BD and AD is the transversal. Okay, in simple language, I have CE, I have BD, and I have a transversal AD going across like this. Okay, so these are parallel lines and that is a transversal. Yes, my friends. Therefore, angle ACE is equal to angle CDB. Okay, one corresponding angles. Angle ACE is equal to angle CDB. Okay, so this is how it is shown. Then, corresponding, my friends, very simple. You can see that ACE, CDB, okay, we are having corresponding angles. So this and this become same. This is first you will prove. Now second, taking BC as the transversal. Now we change the transversal. We now take BC. So I have lines which are parallel and I take BC as the transversal. Okay. Here I will have, okay, therefore angle ECB is equal to angle CBD. Number 2, alternate angles. Alternate angles, my friends, you very well know, are congruent. ECB is this angle, okay, is congruent to CBD, this angle. The Z, okay, we are going for the Z. Now, but angle ACE is congruent to angle ECB. ACE is congruent to ECB. Angle bisector is given. This is given that CE is the angle bisector. That is told to us. Now, this is 3. Now, bringing all together, we will have AC is equal to CDB, AC is equal to this, left hand sides are equal, so right hand sides therefore will turn equal. So that is how we will correspond. Fourth, therefore, angle CBD is congruent to angle CDB from 1, 2 and 3. Okay. Now, fifth, in triangle CBD, side CB is congruent to side CD. CB is congruent to CD. That is, my friends, by our construction. Okay. And also, sides opposite to congruent angles are congruent. Okay, so I will write that instead, sides, because in construction I could not measure, opposite to congruent angles. Therefore, CB is equal to CD. This is number 4. Okay. 6. In triangle ABD, segment EC is parallel to segment BD. That is by our construction. Segment EC is parallel to BD. We constructed, dotted line is shown. Therefore, AE upon EB is equal to AC upon CD by, we just proved, basic proportionality theorem. And this is number 5. If a line is parallel to the side of a triangle and intersects the other two sides, then the ratio in which it intersects the other two sides are same. Okay. Now bringing 4 and 5 together, or changing as you would say, I will get finally, therefore, AE upon EB is equal to AC upon CB. I will change this by using this. Okay, and I will write here from 4 and 5. Hence proof. That is how to do the angle bisector theorem. Yes, my friends, angle bisector theorem. Again important, we will be using it in the sums. Please give it a look and practice. Okay, so we will need this again and again to do our now exercise 1.2. Exercise 1.2, page of your textbook, number 13. Exercise 1.2, page number 13 of your textbook. We will begin. First, sum. Given below are some triangles and lengths of line segments. Identify in which figures ray PM is the bisector of angle QPI. In which figure is ray PM bisector of angle QPI. I remind you, angle bisector theorem. The side bisected ratio is 1:2. The remaining sides ratio is 3:4. 1/2 is equal to 3/4. We will check it out. So first, given A, they have given a triangle PQR, and this goes here. It cuts at M. This is 1.5. this is supposed to be 3.5, this is supposed to be 7, and this is supposed to be 3. This is what they have given us in the first diagram. Now, point M is on side QR of triangle PQR. So we have identified where is M. So that is the bisected side. Then we will go for the ratio. So according to us, PQ upon PR is equal to 7 upon 3. So 3 upon 4, which in our diagram is equal to here 7 upon 3. Then this is 2.3 recurring. That is 1. Next, we will take the bisected sides. QM upon MR is equal to 3.5 upon 1.5. That is equal to 2.3 recurring. That is number 2. From 1 and 2, we get PQ upon PR is equal to QM upon MR. 2.3 recurring we get. Therefore, ray PM is bisector of angle QPR, converse of basic proportionality theorem. If ratios are equal, the line is parallel. That is how to do the sum. We will look at the next diagram after this. As simple, all will have same methods. We will be only changing the values given, so that and the diagram is just rotated, so nothing great. Okay, same steps will be written, and you would be following the same ratios. So in the second diagram, okay, the numbers are different, so you will divide the numbers and you will check it out that in the second diagram, B part of the first sum, you will check it out by putting PQ, PR, QM, MR, that the ratio is not equal. That in the second sum, I will get PQ upon PR is equal to, in my textbook, it is given to be 0.70, that is 1. And the second ratio, QM upon MR, when you divide the sides, will be equal to 6 upon 8, that is 0.75, number 2. And as you can see, they are not equal, so PQ upon PR is not equal to QM upon MR. Therefore, ray PM is not the bisector of angle QPR. That is how we will go. Same reason we will written, converse of BPT. In the third sum, similar, okay, I will get PQ upon PR as 9 upon 10, that is 0.9, okay, that is 1. And when I take the other QM upon MR, I will get 3.6 upon 4, that is also 0.9, that is 2. So I will write like the first case. So from here, I will write from the first case. I will copy this. So it is angle bisector. Just like the first sum. Okay, so these were the 3 parts in the first sum. And of course, we will be writing the reason. Converse of BPT. Never forget the reason. Half mark will go. That is how to do the first sum. So they have made you do 3 times so that it stays with you and you are able to do it in the exam. Okay, so let us see second sum. Please do all the 3 sums. Although it is repetitive, I am trying to complete maximum before your exam, okay, and cover up your loss of time. You must practice all. You cannot skip, otherwise you will falter in the exam. Okay, going further. Second sum. Repetitive means it will finally remain in your brains. In triangle PQR, I am given a triangle PQR. Okay, PQR. In this triangle, PM is 15. So here I have a line, I have a M, and they have given this to me as 15. PQ is 25. PQ is 25. And PR, sorry, and PR, okay, is 20. And they have also given NR is equal to 8. State whether the line NM is line NM parallel to side RQ with reasons. Reasons means you must solve, not write orally in one line, yes or no. So this is what the sum is given in the book. Okay, the diagram is same. I've copied from the book. I've just put the numericals there. Now we need individual sides. I have one, I must find the other one. I'm complete, I have one, I must find the other one. Otherwise 1 upon 2 cannot be equal to the other side 1 upon 2. So that is why we will first have to derive. First, Pn plus Nr is equal to Pr between S. Pnr. R is between P and N is between P and R in a straight line. Now, therefore, Pn plus 8 is equal to 20. Therefore, Pn is 20 minus 8, that is 12. So I've got now this as 12, I have found out. Similarly, we'll move to the other side. Second, Pm plus Mq is equal to Pq because between S, M lies between P and Q on the line. Okay, Pm is 15 and PQ is 25. Okay, therefore MQ is 25 minus 15, that is 10. So I have got MQ is equal to 10. And this is what I have found out. So, okay, therefore, and we also have PM is 15 and MQ is 10, two things which I found out. So I will go further, step 3. Pn upon Nr is equal to Pn upon Nr is equal to 12 upon 8. Okay, when I divide 4 2s are 4 3s are, I will get 3 upon 2, that is 1. Okay, then next, Pm upon Mq is equal to 15 upon 10. 5 2s are, 5 3s are. So that is number 2. Okay, now I can see fifth, Pn upon Nr is equal to Pm upon Mq is equal to 3 by 2 from 1 and 2. Because numbers might look same, you can go for Roman numbers so that you are not confusing. Otherwise, which two? Okay, so that is why we will change the way we write the numbers. Now when ratios are equal, 6. Therefore, line NM is parallel to side RQ by converse of basic proportionality theorem. That is how to do the sum. Such simple. Sum number 2. Okay, just like sum number 1, find the ratios. Ratios are equal, then our line is parallel. Okay, we'll go for sum number 3. Simple or difficult? Please practice that sums till you are fluent with them. Do not assume, on seeing, I know this. Never try that. It will fail you at some time. And all will fall like dominoes. Everything will fall. Sum number 3. Nervousness results when practice is poor. Diagram is given for us. Our diagram from the book. I have N, I'm told angle bisector, P, 7, 5, M, Q, and I'm told 2.5. This is what I have in my diagram. So, in triangle MNP, I have NQ is the bisector of angle N. MN is 5 and PN is 7. Okay, and MQ is 2.5. Find QP. To find QP, how much is this? My friends, turn the diagram and you will see that 1 upon 2 is equal to 3 upon 4. It will become simple angle bisector theorem. Now, how to write? In triangle MNP, ray NQ, our ray, is the bisector of angle N given. Okay. Therefore, Mn upon Np is equal to Mq upon Qp. How? Angle bisector theorem. Theorem on angle bisector. You don't have to write the complete theorem. We mention the theorem. Therefore, 5 upon 7 is 2.5 upon QP. Therefore, QP is equal to, okay, 2.5 multiplied by 7 and divided by 5. And I will get 3.5. Okay, this is my answer. Answer, QP is 3.5. Make a square box and you will get full marks. As simple as that. Please write the answers distinctly and separately at the end of the sum. If nicely, you can square box it so that it is visible, outstanding to the examiner. We will move to sum number 4. We'll move to sum number 4. And the diagram looks like, I have A, I have P, I have Q, I have B, I have C. I have 60 degrees, I have 60 degrees. Okay. Then, measures of some angles in the figure are given. They have given me angle P is 60, angle B is 60. Prove that, I have to prove. To prove that, okay, AP upon PB is equal to AQ upon QC. Okay, I have to prove that this is what I am having is basic proportionality theorem. This is what I have to prove. Okay, now first, in triangle ABC, I have point P is on side AB because APB between us. Okay, point Q is on side AC, again between this, which we have to establish. The points are on the other two corresponding sides. Then in triangle ABC, side AB is transversal. It acts like a transversal of side of parallel sides BC and PQ. So I have like this and I have this like this, B, P, A. So this is how I see the figure. Okay. Therefore, these, as you will see, are corresponding angles. Okay. Therefore, angle APQ and angle AQC form corresponding angles. Okay. But angle APQ is equal to angle ABC, that is 60 degrees, that is given in the diagram. Now when corresponding angles are equal, the lines are parallel. Therefore, okay, segment PQ is parallel to side BC. Okay, number 1. And the reason is corresponding angle test. Corresponding angles test of parallel lines, which we studied in our 9th standard. Okay. Now, 4th. In triangle ABC, point P is on side AB and point Q is on side AC. It is given in the figure. Therefore, I have segment PQ is parallel to side BC. From 1, where was this? Okay. From 1. So I have AP upon PB should be equal to AQ upon QC by basic proportionality theorem. Hence proved. This is what I had to prove and this is what I have already proved. Okay. So this is how to go about the sum. Okay. We will look at sum number 5. Okay. You don't have to draw broken diagram and all. These are my explanations to you so that it's easily visible to you. You don't have to draw arrows like this. Be neat in the exam. Okay. Of course, if you use a pencil or you'll have to erase, leave it fair. Don't do rough work on your answers. And anything in pencil is not corrected. So be careful not to first write theorem in pencil and then you forget to ink it and leave that pencil there. And in no case should you strike unless you are sure. So if you've stricken it off, draw a line across, it will never be corrected even if the line may go down on something which is wanted or required. Okay, so you can't say, don't look at the line, etc. Be careful. We will go to sum number 5. Sum number 5, our diagram runs, there is a trapezium. Okay, I have A, B, C and D and I have a P and a Q. Okay. In the trapezium ABCD, AB is parallel to PQ, is parallel to DC. All three lines are parallel to each other. AP is 15. PD is 12. PD is 12. QC is 14. Find BQ. I need BQ. Now, my friends, as you can see here, this, if taken up, okay, looks like a, okay, that is how this fits into this chapter. You can have different transversals, parallel transversals. Now, how to solve? In trapezium, etc., we do not, because it's not a triangle, we will directly write side AB is parallel to side PQ is parallel to side DC. What is given? Okay, and lines AD and BC are transversals. So 3 parallel lines and 2 transversal from your parallel line chapter in the lower class. Now, second, AP upon PD is equal to BQ upon QC. Property of 3 parallel lines and their transversals. Therefore, what I have, AP is 15, PD is 12, BQ I don't know, QC is 14. So, BQ, I'll leave it as BQ for time being. So it's easy for you to imagine. BQ is 15 into 14 by 12. That gives me, as you can see, 17.5 units as the answer. Please write the answer in words and square box 8. This was sum number 5. Let us look at sum number 6. In sum number 6, we have in the diagram M, N, P, 40, Q, angle bisector 14 and 25. Okay, find QP. Now, my friends, angle bisector theorem, you know, 1 upon 2 is equal to 3 upon 4, and you will be able to solve it yourself. I should get QP is equal to 22.4 units. Please practice. So, 40 upon 25 is equal to x upon the 14. And just solve and you should get 22.4 units. So nothing great in this, nothing difficult, and you should practice. These are coming many times, and I would like you to become fluent. So we will see sum number 7. Okay, 7th sum also, we'll see here only. 7th sum, it says in the figure, okay, they are given as a figure. This is AB, this is CD, and this is EF, and this is 8, this is given as 12, this is given as X, and this is given as 4. Okay, just like the sum number 5, now the diagram will become inverted, nothing else. Okay, in the figure, AB is parallel to CD is parallel to EF, and find X and find AE. So we have to find X to find X, and then we will add it to 12 and get AE as a complete segment. Okay, now we will write same steps. At first, these lines are transversals. Lines are transversals as a first step. Which lines? Okay, the transversals are AE and BF. you're writing about AE and BF. Remember, second point you are doing in this case is that these are parallel lines you are writing. That is AB, CD and EF you are mentioning. Third, you will be writing about ratios, 3 parallel lines and their transversals. So we will have FD upon DB is equal to EC upon CA. Okay, and you will write the reasons. From here, same property of 3 parallel lines and their transversals. And here you will get from here you will get EC, that is X is 6 units. Now we'll do addition between this, but AC plus CE is equal to AE because of between the C lies between A and E. AC is 12, EC my friends is 6, is AE is 18 units. Please write the answer separately and this is how you will do the sum. Extremely simple. Same to same so that your practice is up to the mark. So you see we are practicing and 5 and 7 are totally similar except that diagram is just been twisted. Okay, so this is how we will do sum number 7. Yeah, we will stop here today. Thank you. Please go for the study pack and solve extra sums from the study pack. Detailed steps of the solved sums are there. Practice sums are there. Past paper questions are there. Theory is there. Theorems are there. Please register and collect your packs as soon as possible. For registering and collecting, you can message us on our WhatsApp or mail. Everything is described. Please get back to us and kindly share with other friends so that they can also use. May not join is not the question. At least at this time they can benefit. Thank you.